This video will show all the code file of our system. It would be better to explain this code with our pipeline graph. And here you can see the file called create repository. You can think it as the entrance of the whole repository work. This part of code is for semi-structured data in knowledge extraction phrase. It will use the function in create repository core file with crawler techniques. This part is for unstructured data also in knowledge extraction phrase. We'll use the function in NLP Python file. Then goes to the next step is knowledge integration. First, we need to split those nested arrays into different entities like judge, instrument, and citation. That is called data processing. Also, we need to do the format transformation in order to link the URLs from third-party database into our own dataset. This is realized in this Python file. And then we can use this command line to do the ontology construction as another video shows. This file is to classify each case's topics. The model we use here is LDA. Mostly the topic is used for data training. We use them as labels for training to improve our model performance. Here you can see a Python file called about label, and it will transform the tabular data format into the format the model needs. This ticked file is used for generate the citation entity. When it comes to the last step is recommendation algorithm. Here the entrance file is main. First, let's see those queries in this Python file. They are used for interact with GraphDB database to do the basic operation like insert, delete, and check if the case exists in database or not. For graph embedding, we use MetaGraph to vect model. The whole model is in this folder. And here we can see how the dataset looks like. The file under embedding flower is the final output we need, which is embedding matrix. Also, it will generate temp file which is generated by random walk. Then we need to calculate the similarity based on our embedding matrix in this Python file. We calculate and rank them, then return the top 8 ones. In terms of user input, we restrict it as neural citation. Then it comes to two scenarios. One is the case the user input case exists in our database. Another is it doesn't exist in our database. Let's see the first situation. We can find that the query case exists in our database. Then the system starts to do the recommending work. It will return a list that is recommended list, but also we will fetch extra information from our database to provide detailed look into the recommendation. We can store the recommendation into a JSON file. Then that's the output of our system. Also, I wrote an API for further research and survey, where can give users a chance to test the system. The problem here because we used the I didn't wrote the case about the case did not exist in the database in my API because in the ideal way we can do those update in batch like backend rather than those kind of real-time feedback. Next, let's see the situation that the case doesn't exist in the database. It will do first fetch the case information from internet and do the natural language processing. This whole process is very similar as what we did for the repository. The difference is like it is in this place is just for one case, but in our repository it's like hundreds of cases. Here you can see we start the web view and automatically execute the code, including downloading the files, fetch information, and extract the knowledge entity from the unstructured text. Then we will update our database using queries. At last, we need to update our model. Here, just for demo, I set to save time, I set the epochs to very small number. Here you can see our matrix of the model, and you will find more information in the dissertation. about this part. After updating the model, it will start to do the recommending work as previous. Because the performance of the model is not so good, so the output in this scenario might be a bit strange. And here we can check our database. It shows that the new case was inserted.